Okay, now I'm gonna move to 3.2. We talk about what is unusual, and then empirical rule in this section. Okay, so let me highlight it. So first, the goal of this is gonna be using mean and standard deviation. And used for compare sample data. And then we want to try to identify the unusual observations. We also will use the empirical rule to help us see how the mean and standard deviation work together. And then we also want to use this score. Okay, so let's start. Okay. Here's empirical rule. Okay. And if the distribution is unimodal and symmetric, or we call it, this one is like a normal distribution letters. Okay. We will have 68% within one standard deviation. So as you see, below one standard deviation and above one standard deviation. Okay. And I mean, if you split by half because of symmetry, you can see half in the left will be 34%, half in the right will be 34%. Okay. So one more thing you may have to consider, I mean, may have to know that since it is symmetric, right? So half of all the data from the mean will be 50%. 50%. All right, 50% above the mean. And half the other will be below the mean. See that? All right. So 68% will be in between one standard deviation. 95% will be two standard deviation, and 99.7 will be in between three standard deviation. Right. So this called empirical. Yeah. Okay, so some I mean, according to symmetrics, we can find with some, you know, some partial areas, such as from mean minus two standard deviation to mean minus one standard deviation. You can see that was only the green area here. Going to be 13.5%, something like that, right? And the other side should be the same, right? Let me see that. So and so on. We can have some smaller piece, such as like from mean minus 3 standard deviation. It's going to be to mean minus to standard deviation going to be 2.35%. So I'm gonna just move to the next things. One thing I forgot to mention that the notation mute here is actually a population mean. Okay, this is like the mean for the whole population. Okay, so just keep in mind that. And the sigma there is standard deviation. Okay, standard deviation, population standard deviation. So let's use this and move to example 1. So let's read it carefully. Okay, sometimes my laptop had problem, right? Okay, so the mean body wage for women between 18 to 25 years old is 134 pounds. So keep in mind that they give us the mean of what? The mean of body wage. So this number is important. Which is the mean. Okay. 134 pounds is the mean. So I will write 134 in the middle here because it is the symmetric or normal distribution. Okay, so and the standard deviation is 26. So 26 pounds is standard deviation. It's gonna be standard deviation 26 pounds. And because we assume the data has a symmetric unimodal distribution or mount shape, and we're gonna complete the following sentence here. Okay, so according to the empirical rule, right? According to the empirical rule, we have, let's say, if you subtract one standard deviation, say from here, you subtract one standard deviation and you plus one standard deviation for the mean. So what do you get? 108. Because subtract one standard deviation, which is subtract 26, right? You get 108, right? Subtract 26. Maybe I use an algebra for you. Subtract 26. Yeah. And the other hand side, adding 26. Gonna be as the hand side will be 160. Yeah. So that's right way tell you that because you according to the empirical rule, you can right away say 68% of women age in between 18 and 25 years old weight gonna be in between 108 pounds to 160 pounds. Okay. And the percent, I mean the percent of 18 to 25 years old weight between 82 to 186 pounds. Weigh that 82. Okay, so from 108 here, if I subtract for 26. What do I get? I guess 82. Right? And from 160 there, I adding one more 26. What do I get? I got 186. So that means what? Oh, from the mean. If you adding and subtracting two standard deviation, you will guess 82 and 186. And according to the empirical rule, you can right away say this gonna be within two standard deviation, right? Plus and minus two standard deviation. And what is that? How many percent? 95% within two standard deviation there, right? All right. So I would say 95%. Okay. Now, I would like to talk about percentiles. What is that? Right? It's indicate the certain percent take of data fall below that percentile. So if I say the score is in 25th percentiles, then what happened? Then 25% of the test taker are below the score. That makes sense? Yeah. So let's move to example number 2. The mean body weight for women between 18 and 25 years old again. And still, we use the mean as 134 pounds, right? And standard deviation is 26 pounds. So all right, so we want to know what the woman between the age 18 and 25 years old with the weight of 160 pounds. Where's 160 pounds? Okay, so if you adding one standard deviation, which is 126 over here, from the mean, you get 160. Right. 160 pounds. And they say, what is percentile of this? What is the percentile of this? Which mean from 160 and below, how many percent do we have? Right? How many people have weight? How many percent of people have weight less than 160? You know, so I would say you may have to apply the empirical rule and got that. So first, the first half for let me use the other color. The first half for one standard deviation is going to be 34%. Everyone should remember that, right? Go up a little bit. 34%, right? What else? And from the mean to below, it's gonna be 50%. Everyone agree? Oh, 50%. So you adding those together, adding everything together, and keep in mind that's percentiles. Will be equal to below below left, or below area or the left area, say that in percent. Okay, so I'm gonna adding 50 plus 34 and I get 84%. So that's, I'm gonna say 160 pounds have weight in 84% pound. Is that what I said? All right. So when we move to part B, a woman between age 18 to 25 years old has a weight in 16th percentile. Oh, now they give us a 16th percentile. What does that mean? That mean it will be like 16% from the left to the value below from the left, right? So that's going to give you the 16th percentile. We need to shade. We say we need to shade an estimate area under the curve. Represent that. Then estimate the woman wage. Estimate the woman wage. All right, so let's we take a look as some idea from the empirical rule here. We have small part here after after 3 standard deviation, you have 0.15%. Then the area from mean minus 3 standard deviation to mean minus 2 standard deviation will be 2.35, right? Okay, so if you think about let me see, adding 0.15 plus with 2.35, right? And adding with what else? 13.5. What is that equal to? Right, the area, the green one here. It's gonna get let me see, 16%. Right, 16% was is gonna be 0.15 adding with 2.35 to 5 and then adding with 13.5 is 16%. So that means I want all the area from the lab all the way to the left to the mean minus one standard deviation value to get the 16%, right? So let me move down. Uh-oh. So move down. Yeah. And I need to clean this up. Say. Oh yeah. So I need to have to shade the area from all the way to the left to mean minus one standard deviation. So this is going to be 108. Right. And I will shade this by blue. All right. And that's will cost 16%. Okay. So down here I can right away say 16% tiles approximately will be 108 pounds according to the empirical rules. Okay. So now we're gonna move to, so what did we learn? We learned about empirical rule, we learned about percentiles, right? What else? Yeah. So now let's we move to unusual observation. Okay, unusual observation. So to measuring unusualness of an observation is it's going to be a little bit complex. Complex. It actually depend on the unit of measurement. It also depends on the object by measure, and it depends on the where each sample object come from. So what is standard unit? Measure a value relative to sample rather than with respect to some absolute measure. Measurement covert to standard unit are called z-score. And the standard deviations and observations, an observation is away from the mean. So the formula for this score is what? Followed by the data value minus the mean, the sample mean, and then divided by the sample standard deviation. Yes, there. Okay. So you may have to start with like subtract observe data values by sample mean, and then divide the difference by the sample standard deviation. So what we use this score? We use to compare values from the different groups or measure in different units. Okay, so sometimes you can have like for example, when I was in in the other country like Vietnam, they use my GPA in the right at like from 1 to 10. But when I moved to interstate, GPA changed to be like from 1 to 4. So so how can I evaluate myself, or can we transfer my GPA from my home country to here? So this score is one of the way to help us on that. All right, so let's move down and see unusualness here. So if this score greater than 3 or this score less than -3, then observe that as value is definitely unusual. The reason was you see this score greater than 3 mean, you know, just the value is like over 3 standard, like above 3 standard deviation from the mean. So that's like unusual. And this score less than 3 is below 3 standard deviation. So so that is a way we call like unusual. Okay. For the one like greater than 2 or less than -2, this score, we can say the observed data value might be unusual. Okay. And if the z-score is 0, then all deviation equal the mean. That's a special case. So let me see if I can, yeah. So I'm gonna move to examples down here. So daily cash register receipt at local store follow a mount shape distribution with mean is 9,200 per day and standard deviation is 400 per day. So you remember that they give us the mean in here, right? What is that? 9,200. And they also give us a standard deviation in here is 400 per day. So you will just put out the middle one is 9,200, right? And H standard deviation from the mean, say adding 400 or subtract 400, you get to the next level, like from 8,800, right? To 9,600, something like that, right? And so on. So you can subtract 400 more, you get 8,400, right? It's 8,000, and then the next one gonna be 10,000, 10,400. Okay. So now the day, they say the question says the day new employer was high, that the store took in 8,300. Were these an unusual low receipt totals? Right. So look at the graph, and you see 8,300 where it is around, let's say around here. I need to add the color, say 8,200, say here. 300, right? So is that is an unusual? So I'm gonna convert this into this score and see what happened, right? Say z equal to x minus x bar and divided by the standard deviations s. So I have x was 300 minus the mean was 200 and divided by the standard deviation 400. And then you get negative 900 divided by 400 should be negative 2.25. Let me check that, make sure. Yep, that's a good one. So so this is like so this score is in between -2 and -3. Okay, so this is in between -2 and -3. So I'm gonna say might be unusual, right? Might be unusual. 3,300, 8,300. Might be unusual. Okay. All right. So now let's move to B and see what the answer is. All right. We say on Monday we have 10,700. All right. And on Thursday 7,640. I'm pretty sure that 7,640 is gonna be unusual, but what else? Oh, they say which one is more unusual and why? Oh, then we have to use this score to compare, right? So let's say Monday. Let me use the other color, sorry. I'm gonna use Z score for Monday as ZM equal to X Monday minus the mean divided by S. So X Monday was 10,700. Oh. And the minus for the mean was 9,200. And I divide by the S, which is 400. And use calculators, you will get equal to 1/500 divided by 400 will give you 3.75. I mean, this clearly is greater. I mean, greater than 3. If it is unusual, absolutely. But because we are comparing, so we need to find the z-score of the of the store of the income on Thursday also. Right. So please pause the videos and do the z-score for the Thursday and check with my answer. So pause now. Okay, now please check with the answer key. I got negative 3.9, which is less than negative 3, right? And the one above was 3.75, which is greater than 3. So they both this score beyond beyond 3 standard deviation from the mean, right? So unusual, both unusual. Unusual, double L, wrong. Yeah. So however, because you comparing between to this, so keep in mind that for the more unusual, more unusual. You will have to ignore the positive and negative side. So you can see that 3.9 is greater than 3.75. So you are gonna say Thursday has more unusual. That's it. Yeah. So let's move to the example number 5. So example number 5, asking give us the mean price of the brand 3.12, standard deviations 0.89, find z score, and then find the score of the breast that costs 2, right? And check if it is unusual. So I will ask you guys to pause my video again and practice on this and check with my answer, right? Go ahead and pause this. Okay, so keep in mind that we have in here the mean price was X bar is 3.12, have standard deviation is 0.89, and we want to convert the X value in here is 2 into z score. So then follow the formulas, you should get like negative 1.26, and which is greater than negative 2. So so this value is actually not an unusual, right? So I would say $2 is not unusual. Okay. Next one. So we have mean individual was 65 degree and standard deviation 8 degree. Okay, so this was San Francisco, right? I have so San Francisco, and then the second one is Provo with the mean 68. I'm sorry, 67. Standard deviation 21. So the check we want to check is 52 more unusual in San Francisco or in Provo. So we have to we have to compare in this guy too, right? You have to compare with the word more, right? You got more. So we have to find the San Francisco z-score by using the formulas x minus x bar again divided by s. And here that x in here is 52. I mean both for both San Francisco and Provo, right? 52 minus 65 divided by 8. And you should get like negative 1.625. Okay, this one is not unusual, but because we want to compare, so we may have to look up the z-score for the Provo also, right? So go ahead and pause my video and do the Provo individually and come back. Okay, so here's what I have is gonna be z Provo. For Provo will be negative 0.71. And again, in order to compare, we have to ignore the positive and negative sign, right? To compare. So we have for the ZSF, which is negative 1.625. And for the Z Provo, you have negative 0. I mean, you can just take away the negative 0.714, and then you compare those. So which one is greater than? So 1.625 greater than. So so that's you're gonna say the San Francisco has have 52-degree more unusual. Okay, more unusual. So I stopped. I finished my 3.2 here, and I'll stop the videos. See you in 3.3 later.